Hi everyone, welcome to goclasses. So before we start, please tell me, audio video volume, is everything clear? So let's start now. In the last session, we have done a lot of gate questions from this topic relations. Now in this session, in this lecture, we will see the remaining questions, the remaining gate previous year questions from the topic relations. We will see. Okay, so let's start now. So this is basically relations in discrete mathematics, gate previous questions part 2. Let's see. Let's see the question type 3. We have already seen two type of questions. We have seen a lot of gate questions we have already solved in the last session. The complete playlist you can find in the description. Okay, the complete discrete mathematics gate PYQ playlist you can find. The link is in the description, so you can check it out. Now let's start this session. So question type 3. From this topic relations, what type of questions they ask in the GATE exam? So the next type of questions they can ask you, that is counting relations. Counting different type of relations. So let's see this. So the first question is very natural, that how many relations are possible on a set of n elements. So if you have a set of n elements, then how many relations are possible? This is a simple question. So let's solve it. So you can check, this is a GATE 1987 question, that how many binary relations? Binary relations means a relation from a relation between two elements. Okay, so how many binary relations are there on set A with n elements? So you have a set A. What you have? So there is a set A, and you are basically you are defining a relation on set A. Relation R you are defining on set A. First of all, what it means? When you define a relation on set A, what it means? Relation on set A, this simply means that this relation is from set A to set A. Elements of A are related to elements of A. Correct? Okay. So the elements of A, they will be related to elements of A. For example, the elements of A can be ABC. So elements of A are ABC. Now they are related to elements of A. Elements of A are related to elements of A. So something like this. Now this you can clearly see, this is a relation. So this is a relation from set A to set A. Okay. Now what you can say, if you have a relation from set A to set A, then you can say that this relation is subset of A cross A. Okay, so this is the point that we can use. We can simply say that every subset of A cross A is a relation from A to A, and every relation on A is subset of A cross A. So finally, what is the A cross A cardinality? We want to find how many relations are there. See, very simple thing, that we want to count what is the total number of relations. This is what we want to count. We want to count how many relations are there, how many number of relations on A. So that will be equal to what? Number of relations on A, that will be equal to what? That will be equal to how many subsets you can create of A cross A. So that will be equal to number of subsets of A cross A. Correct? Okay, very simple question, because you know that every subset of A cross A will be a relation from A to A, and every relation from A to A is a subset of A cross A. So relation is basically, this is the definition of relation, let me tell you. So this is the definition of relation, that relation on set A is subset of A cross A, because you are relating elements of A to elements of A. So for example, you can simply see this is a subset of A cross A. So here you can easily see this diagram. You can easily see this diagram. This you can see, this is a subset of A cross A. Okay, so finally I can say that number of relations on set A, that will be equal to number of subsets of A cross A. Now what is the cardinality of A cross A? You have a set A such that the cardinality of A is given to you n. Then what is the cardinality of A cross A? You know what is A cross A? That is Cartesian product. So that is basically set of ordered pairs. A cross A is a set of ordered pairs. In A cross A, every element is an ordered pair where the first element is coming from A and the second element is also coming from A. This is your A cross A. So what is the cardinality of A cross A? The cardinality of A cross A, that will be equal to how many ordered pairs you can create. This type of ordered pairs you have. You can see in A cross A you have this type of ordered pairs. So how many such ordered pairs you can create? You can easily see that the first element is coming from A, the second element is coming from A. So this first element has n choices because the cardinality of A is n. A contains n elements, so the cardinality of A is n, so this X has n choices. Similarly, this Y has n choices because number of elements in A, that is n. Okay, so X has n choices, Y has n choices, so the cardinality of A cross A will be n into n, that is n square. Okay, this is the cardinality of A cross A. So what is the now? So you can see this A cross A, this has these many elements. So how many subsets will be there? So what will be the number of subsets? What is going to be number of subsets of A cross A? So number of subsets of A cross A, that will be equal to how many subsets you can create. Remember, in this A cross A, you have total n square elements. These many elements you have. So how many subsets you can create? That will be 2 power n square. Okay, this will be the number of subsets of A cross A, and this will be equal to number of relations. And this will be equal to number of relations on set A. Okay, on set A, how many relations are there? That will be equal to 2 power n square. Okay, is this clear? See, this is a very simple question. I hope you understood. The question is extremely simple because the question is asking how many relations are there on set A. So you can see that if you have a relation on set A, then that is same as that relation is subset of A cross A. So number of relations will be number of subsets of A cross A. So in this A cross A, you have total n square elements. In this A cross A, total n square elements you have. So how many subsets will be there? So for this A cross A, there will be 2 power n square, these many subsets you can create. Okay, and if you can create these many subsets, that is your number of relations. That is your number of binary relations. So this is your number of relations on A cross A. Number of relations on A. On this A, how many relations are there? That will be this. Now, what variation they can ask you in this question? In this question, what is the variation they can ask you? So let's see. What is the variation they can ask you in this question? This type of variation they can ask. So let me tell you. A variation that they can ask you is this. Instead of binary relation, they can ask you how many ternary relations are there on set A. Okay. So this type of variation they can ask you how many number of ternary relations. Number of ternary relations. Ternary relations on A. Okay. Such that this A has n elements. So what is the answer for this question? This type of variation they can ask you. This is a variation in this question. This type of variations they can definitely create this type of variation. What is the number of ternary relations on set A? So first of all, let me explain what is this ternary relation. Let me explain. Ternary relation, this simply means that you have a relation between 3 elements. Okay, so this simply means that you have a relation among 3 elements. Among 3 elements. These elements can be same or they can be different, but the point is that this is a relation among 3 elements. So let me give you example. For example, if this A is A comma B, let's assume in this A you have 2 elements, or maybe you can take 3 or 4 elements, you can take A, B, C, D. Let's assume this is your set A. Then what is a ternary relation? This R is a ternary relation, means now it will have a triple. Now it will have this type of ordered triples it will have. For example, maybe A is related to C. Okay, so this is possible. Also, maybe A is related to B and that they are related to D. Okay, also maybe B is related to B. Okay, so this type of triples you will have. So are you getting my point? What I'm saying, that this is your ternary relation. So in a ternary relation, first of all, let me tell you what is a ternary relation R. on set A. So what is that? Ternary relation R on set A. So that simply means that your relation R, that is like this. In this relation R, you have total basically three elements are related to each other. Okay, X, Y, Z. So that all are coming from A. Okay, all are coming from A, and they are related in some way. Okay, they are related to each other in some way. I can say that X, Y, Z, they belong to R. Okay, so they are related to each other in some way. So this is your ternary relation. Is this clear to everyone? So you can easily see, look at this ternary relation. Just look at this relation. Can you see that every ternary relation is a subset of A cross A cross A? So here I can say this ternary relation, this will be subset of A cross A cross A. That's it. This is all you have to know. Okay. This is all you have to understand, that every ternary relation, this is a ternary relation. Every ternary relation is subset of A cross A cross A. That's it. Now, how many elements are there in this A cross A cross A? That will be n into n into n. That will be n cube elements. Okay, that will be n cube elements. So in this A cross A cross A, there will be n cube elements. Okay, and every subset of A cross A cross A will be a relation. So how many subsets are there? How many number of subsets of A cross A cross A? So what that will be? Number of subsets of A cross A cross A, that is going to be 2 power n cube. That is going to be 2 power n cube. So this is your number of ternary relations. So finally I can say that the number of ternary relations, how many ternary relations are there on set A, that will be 2 power n cube. So can you generalize this? Can we generalize this? Tell me, can you generalize this? Instead of ternary, if the question will ask you about an array relation, this is the generalization, right? Yes or no? Correct. So they can ask you this variation. They can ask you maybe M array relation. Maybe they can ask you M array relation. So how many M array relations are there? So first of all, what is M array relation? Let me tell you that this M array relation, okay, what is this M array relation R on set A? What is this relation? This relation is basically, I can say this is subset of A cross how many times? M times. How many times? M times. M times A. So I can say, so in simple words, I can say, in simple words, we can just simply say it is subset of A power M. Okay, it is subset of A power M. That's it. So finally I can say how many M array relations will be there. So that will be answer will be 2 power n power m. This will be the answer, because you can easily see that your relation is subset of A power m. In this A power m, how many elements are there? In this you have n power m elements. These many elements you have. So how many subsets you can create? So from this, how many subsets you can create? So number of subsets that you can create, subsets. So that will be 2 power n power m. So this will be your answer, 2 power n power m. So these are the variations they can ask you in this question. I hope you understood. Please tell me the complete analysis of this question. Did you understand? Let me know. Did you understand the complete analysis of this question, that how many relations are there on set A? You have a set A. On this set A, how many relations are there? Okay, how many binary relations are there? How many ternary, how many n array relation are there? So you can easily find. Okay, very easily you can find. Now let's move on. Now let's move on to the next question. That is, so this is actually important result. Let me tell you, these are the important results. Like this result is basically important because many times this question has come in the GATE exam. This question, that how many number of binary relations, how many binary relations on set A, such that this set A has n elements. This question has come in the GATE exam many times. Okay, so this is an important result, that how many binary relations you can create on set A. That will be same as number of subsets of A cross A. That will be same as number of subsets of A cross A. and that will be same as 2 power n square. Okay, so this is an important result. uh, you don't have to remember it, okay, because you have to understand it. Because remember, in the question, in the gate exam, they can ask you anything. They can ask you any variation. Gate exam is all about variations. They can ask you any variations, so you can easily see this. Okay, let's move on to the next question. This is another gate question, gate 1999 question. The number of binary relations, how many binary relations are there on a set with n elements? So the answer will be what? That will be 2 power n square. So this we have already seen that the answer is 2 power n square. Okay, very easily. So what is this? This is number of subsets of A. Remember, this is the number of subsets of A. This is the number of subsets of A. Okay, how many subsets of A? That will be 2 power. That will be 2 power n. And what is this? And what is this one? This is the cardinality of A cross A. This is the cardinality of A cross A. This option A. Okay, so this option A is the cardinality of A cross A, and option B is the number of subsets of A. So I can also say that this is cardinality of power set of A. This is cardinality of power set of A. Okay, so let's move on now. Let's see this question. This is another good question. This is GATE 2002 question. Okay, what the question is saying? The question is saying that let A be a set with basically non-empty set. Okay, basically this A is basically a non-empty set. This A has at least one element. Okay, so this is a non-empty set. NR is the number of binary relations on A. NF is the number of functions from A to A. Okay, so this NR, this is the number of binary relations. How many relations are there on set A? On set A, how many relations are there? And NF, this is number of functions from set A to set A. Now we have to find NR. NR we have to find. We have to find NF. Then for the large values, we have to find the relation between them. Okay, we have to find the relation between them. So let's solve this question very easily. You can solve this. So we already know that if you have a set A and the cardinality of the set A, that is n, number of elements in set A, that is n, right? Okay, now you tell me what is the number of binary relations, what that will be? What is the number of binary relations? What is that? Number of binary relations on A, that is your NR. Number of binary relations, that will be equal to 2 power n square. This we have already seen. So that will be 2 power n square. What is the number of functions? What that will be? Like, what is the number of functions from set A to set A? Number of functions from A to A. Okay, from A to A, how many functions are there? So you can see that this is the domain. You can see that this is the domain and this is the codomain. Okay, so how many functions are there from set A to set A? This is the domain, this is the codomain. So number of functions that we have, what is that? Number of functions, how many functions can we have from set A to set A? So that is equal to n power n, right? Okay, because why? What is the reason? Let me tell you. So how many functions are there? So let's see this function from A to A. So you know that this is your set A. In this set A, you have total n elements. This is your set A. In this set, you have total n elements. Now, how many functions you can create? So number of functions that you can create. Number of functions from A to A. How many functions can you create? Let's check it out. So you can see when you create a function, then for every element in the domain, this is your domain. Okay, for every element in the domain, for every element there is exactly this element can map to this, or this element can map to this, or this element can map to this. So this element can map to exactly one element. So I can say for this element total how many choices you have? Total n choices you have. Total n choices you have, because it can map to this one, or you can map this 1 to 1, or you can map 1 to 2. So there are n choices for 1. Similarly, there are n choices for 2. Similarly, we have n choices for 2. This 2 can map to 1, or 2 can map to 2, or 2 can map to n. So there are n choices. And for this also there are total n choices, because this n can map to 1, or this n can map to 2, or this n can map to n. So every element of the domain has n choices. Okay, every element has n choices. So finally I can say that n power n, this is the number of functions from a to a. So we got your number of functions we got. So the number of functions, that is your nf, that is given in the question as nf. So we found nf, we found nr, both of them we have found. So what your nr will be? Nr will be 2 power n square. This will be nr, and nf will be n power n. Okay. Now what is the relation between them? What is the relation? We have to find what is bigger. So the question is, who is bigger? Like nf comma nr. Okay. So which is bigger? Which is bigger? Which is bigger? Which is larger? Like number of relations from a to a, is that larger, or number of functions from a to a, is that larger? So this is what we have to find. So let me tell you method number 1. That is very intuitive method. What is method number 1? That is very intuitive, or I can say logical method. Let's see a logical way. Logical method. What is that? See, can you see that every function you can think as a relation? Yes or no? Correct. Every function is also a relation. Every function from a to a, can be thought as a relation on a. So you can easily see that every function from a to a, whatever function you take, every function from a to a is also a relation, on a. Okay, very easily, like whatever function you take. For example, if this is your set a 1 2 3, this is your set a 1 2 3. Now whatever function you take, for example, let me take this function. Let me take this function. So consider this function. So you can easily see this is a function, right? Okay, you can easily see this is a function. This is also a relation. So every function is also a relation. Agree? Correct? But remember, you can create more functions, more relations you can create. So very easily you can see that every function itself is a relation. Okay, this is something that you can easily observe, that every function from a to a is also a relation. Okay, so every function is a relation. Now you can also see. So this is your, I can say, we are going through method 1, that is logical way. How to logically solve it? How to logically solve this question? So you can easily see that every function is a relation, but you can create relation which are not functions. Okay. So for example, you can create this a, and this is your a, like 1 2 3 1 2 3. You can easily create a relation which is not a function. For example, you can create this. Now if you do like this, then definitely this is not even a function. Okay, this relation, look at this. So this is a relation but not a function. So this is a relation but not a function. This is a relation but not a function. Okay, so you have a relation but not function. So finally this point I can say that, what you can say that number of every function is a relation. These are the relations on a. Okay, these are the relations on a, right? Okay, these are the relations on a, and these are function from a to a, So every function is a relation. But there are relations which are not functions. Okay, so clearly you can see that this will be bigger, right? Yes or no? So I can say number of relations, that will definitely be bigger than number of functions, right? Yes or no? So very easily you can see that number of relations will be definitely bigger than number of functions. Number of relations on a, number of relations from a to a, that will be bigger than number of functions from a to a. This is your logical way. But let's see another way. Let's see the method number 2. Let me also give you the method number 2. So what is the method number 2 to solve this? So you know the value. Let's comparing value. Okay, mathematical way. Let's see the mathematical way. Method 2. So you know the value. What is nr? nr is 2 power n square, and nf is n power n. Let's see what is bigger. Let's see out of these two, what is bigger, which is bigger, which is bigger value. Tell me, which is bigger value. So in your algorithm subject, you have this type of functions, right? Yes or no? Asymptotic comparison you can do, correct? So for example, if I give you n power n, if I give you 2 power n square, which looks bigger, which is looking bigger, tell me, how can you compare them? Which value is bigger? How will you compare them? Tell me. Like I give you two values, n power n, 2 power n square, which value is bigger? So tell me. Simple question I am asking. I am asking, forget about everything. You just tell me which is bigger. Two values I am giving you. I am giving you n power n. One value that I am giving you is n power n. Another value that I am giving you is 2 power n square. And which of them is bigger? Which of them is bigger? Let's see this one. So, how will you solve this? Can anyone tell me? How are you going to solve this? No, don't take log and all. Okay, let's check them. So let me tell you, don't take this logarithm and all. So this is actually misconception. So first of all, remember this is the wrong way. What is the wrong way? If you want to do their asymptotic comparison, what is the wrong way? So basically like asymptotic, let's do the asymptotic comparison. Asymptotic comparison. Asymptotic comparison. So what is the way? So the wrong way, let me tell you, the wrong way is taking log. Wrong way is taking log. This is the wrong way. Let me tell you. Okay. You can easily see actually what happens. Let me tell you, I will not go into the detail. I will not tell you all the details, but let me tell you, this is a monotonic function. This logarithm, this is a monotonic function. So if f1 is bigger than f2, then log f1 also will be bigger than log f2. See, this is a monotonic function. This log, this is a monotonically increasing function. Okay, so what this means that if f is bigger than g, then log f will also be bigger than log g. But the most important point is that because of this logarithm, this asymptotic growth can become equal. Okay, the asymptotic growth can become equal. So what I'm saying, for example, this is what I'm saying. Asymptotically, you cannot compare them. For example, if like you can say that n square, this is greater than n. But you can see that if you do the logarithm of this, that will be log n. If you do the logarithm of this, this will be. So you cannot compare them asymptotically. Asymptotically, they are same. Asymptotically, they are same. So you cannot compare them asymptotically. Okay. So this is a wrong way. So this is actually very common. Let me tell you, most of the students, they use this method. Majority of the students, they use this method. Okay, and this is actually a wrong method. There are many TIFR questions. Let me tell you, in TIFR exam, many questions are there in which to compare asymptotically, if you want to do asymptotic comparison, and if you take this logarithm, then you will get wrong answer. So you know, these TIFR people who create the TIFR question, they know, they are aware that students are using this wrong way, this wrong method students are using. So that is the reason they are creating questions such that if you use this wrong method, if you take logarithm, then you cannot compare asymptotically. Okay, this asymptotic comparison you cannot do. So that is the reason. So don't take this logarithm and all. Okay, now let's see the correct way. Let me tell you very clearly, I am telling you that this log is a monotonically increasing function. This log, if you see the graph of the log, then that is actually monotonically increasing. Okay, this log is a monotonically increasing function. So if f is greater than g, then log f is also greater than log g. Okay, so for example, if this is your f, if this is like if g is greater than f, then log f is less than log g. So you can see this is you can clearly see this is monotonically increasing function. Okay, this is I can say this is log f and this is log g. But the point is, that asymptotically comparison you cannot do. This asymptotic comparison, so this taking log is wrong way to do this asymptotic comparison. Okay, so let's see the correct way. Then what is the correct way then? Then what is the right way? Then what is the correct way? So let me tell you the correct way. Which is bigger? The best way, these TIFR question I was talking about, right? Yes or no? These TIFR questions, on asymptotic comparison, okay, so these there are many TIFR questions on asymptotic comparison. So here the wrong way, as you know, the wrong way will be the wrong method. This is actually a wrong method, you should not use it. But actually there is a problem that many teachers are also teaching this wrong method, so that is the reason students are using this. Okay, so anyway, you should follow good resources. You should not follow like very poor quality resources. You should not follow. So anyway, the wrong way is taking log, and the right way, what is the right way? Let me tell you the right way. Make the base same. Make the base same. Okay, I will explain this. What is this? So let me tell you, you can use this property whenever you have this confusion, like so a power b and c power d, which is bigger. Whenever you have this comparison, okay, whenever you want to do this asymptotic comparison, if you want to do this asymptotic comparison, then what you can do? If you have this a power b and another you have c power d, if you want to do this asymptotic comparison, then what you can do? You can use this property of logarithm. There is a property of logarithm that if you have this x, what you can write? This x you can write y power log yx. Is this property? Do you remember this property of logarithm? This is a very important property of logarithm. This is an important property of logarithm. So what is this property? This property is saying that x, whenever you have something, like whenever you have a, what you can do? You can write it any b power log b a. Like this you can write. Okay. So what you can do, for example, if you have anything like you have alpha, so what you can do? This alpha you can put here, and anything beta log beta, beta power log beta, and like this you can put. So this property is very useful property. Okay, this is a very useful property. What you can do? You can just simply do this. Now, for example, this a power b, this c power d. Now at this point, what you can do? You can make their base same. So here, this is the base. Here, this is the base is a, and here this is the base is c, right? You can make their base same. What you can do? This a power b, here also you can make the base a. So what you can do? You can do a power, what you can do? You can write like this, a power log a c power d. Now you can easily compare. Tell me, did you, okay, yes or no? This is a very nice way, correct? And this is a correct way. See, this is a mathematical way. This is what you can do. Now you have the same base. Now you have the same base. Now you have to compare. Now you have to compare this value with this value. Tell me, yes or no? This is the correct way. This is the mathematical way. Now you have the same base, a. Now you have to compare this with this. So tell me, did you understand this method? Let me know. Let me know, did you understand this method? This method, did you understand? So you can now you can see, now you have the same base. So this is what I'm saying, that whenever you want to do this asymptotic comparison, whenever you want to do the asymptotic comparison means basically for large values. That automatically means that you are comparing for large values. Okay, comparison for large values. So you can see that this asymptotic comparison, this is automatically equivalent to comparison when you have large values. Comparing for large values. So you can see this taking log, this is a wrong way, and right way is make the base same. So you can just use this method. this x you can write as y power log y x. So like this you can write, okay, very easily. So this is how you can make the base same. Now let's solve this question. Very easily you can solve it. So let's make the base same. Now you can easily make the base same. For example, what you can do, this is your 2 power n square. You can also take it as 2 power n square. Okay, let's make it 2 power n. So what you can do like this, 2 power, you can write it log 2 n power n, right? Yes or no? Correct. This is same as this. Now what is this? This is equal to 2 power log 2 n. Now what you have to compare? Now you just have to compare this and this. Okay, this versus 2 power n square. So now the base is same. You remember, now the base is same. Now all you have to compare, this comparison you have to do with this and this. So you can see this n log n and n square. Tell me which is bigger? N log n, which is bigger? N log n square, which is bigger? So you can clearly see that this is a bigger. Okay, you can clearly see this is a bigger. Very easily you can see this is asymptotically bigger. This is asymptotically bigger. So you can actually like this. So this is asymptotically bigger. So finally I can say, once you make the base same, so you can see this n power n, you can write it 2 power log 2 n power n. What you can write it? You can write it 2 power n log n. Okay, and the other is 2 power n square. Now you can easily compare this function, this value and this value. Now you can easily compare, and you can say that this n power n is basically small o of 2 power n square. This is small o. This is small o. So that's it. So finally I can say that if you have large values, remember for large n, what you can say for large n, what you can say? You can say this number of functions is a small o of number of relations. Remember, this is small o. Okay, this is small o. So I can say this n power n, this is very less than 2 power n square for large values. I hope this is clear. Tell me, this is your method number 2. Did you like it? Please tell me. Did you understand this? And did you you can see this is purely mathematical way. This is pure mathematics. Okay, we are not doing any stupidity. We are not taking log and all these things. This is purely mathematical way. So like this you can solve a lot of questions you can solve. Okay, whenever you want to solve, this is what I want to do. Not whenever you want to compare, asymptotic comparison if you want to do, for example, okay, asymptotic comparison, this asymptotic comparison if you want to do, asymptotic comparison, that simply means, okay, this asymptotic comparison, this simply means that comparing for large values, comparison when large inputs. Okay, so when large inputs, so these two things are same. So what you have to do? All you have to do the correct way. What is the correct way? The correct way is make the base same. Make the base of power same. This is what you can do. Is this clear? Make the base of power same. Whenever you don't have to worry. For example, if one function is f and another function is g power h, then what you can do? Then this f you can convert into g power log g f. Okay. Now you can easily see, this is g, this is g. Now you have to compare. Now this question is nothing but you have to compare this value with this value. Okay, so this is how you can solve it. Very easy method. So I hope you understood. So let's go back to the question. So the question is asking that which is bigger for large values. For large values, which is bigger? So you can easily see that for large values, this NR is very, I can say this NR is much bigger than NF. Okay, number of relations on A, that will be much bigger than number of functions from A to A. Or you can easily see, or you can write like this. So we can also write like this, that this this nf, this is small o of nr. This is small o of nr. So like this also you can solve. So this is your question. A very good question, you can see GATE 2002 question. So we have seen this complete analysis we have done. Please tell me, did you understand? Let me know, did you understand this complete analysis? Did you understand? In one question we have seen a lot of concepts. Please tell me, did you understand this question? Now let's move on. Now let's see this question. This is another GATE 2010 question. So how can we solve it? Let's see this. GATE 2010. So what are the possible number of reflexive relations on a set of 5 elements? So the question is asking number of reflexive relations. How many reflexive relations are there on a set of 5 elements? So let's check it out. Let me tell you that the best way to find out number of reflexive relations, what is that? That is your matrix. You can create a matrix. The matrix representation is a good way to find out, to calculate number of relations. So this is something that you can easily use that. Basically this matrix representation. Matrix representation. Matrix representation of a relation is a easy way, or I can say is a good way to count number of relations. To count number of relations. So if you want to count number of relations, then this matrix way, this matrix representation is a good way. This matrix representation, this is a good way if you want to count number of relations. For example, let me tell you. Okay, let's see now everything. Now we will see in this question. So this matrix representation you create. What you do, you just create this matrix representation. For example, let's see the application 1. Like how many number of relations on A? Let's see this one first. Number of relations on A. Let's assume A has n elements. So number of relations on A. How will you calculate this? How are you going to calculate this? Just use the matrix representation. We want to find number of relations on A. So first of all, you use the matrix representation. So in the matrix, this will happen that in this A you have n elements. In this A you have total n elements. So total how many cells will be there in this matrix representation? How many cells will be there? So in this matrix representation there will be n square cells, right? Yes or no? Correct. There will be n square cells will be there because this is a n by n matrix. This matrix is n by n. So there will be n square cells. In this matrix total we have n square cells because this is a n by n matrix. So that is the reason we have total n square cells. Now for every cell, what you have? For every cell you have two choices. Correct. For every cell there are two choices. For example, here there are two choices. Either this is 0 or this is 1. There are two choices here. Either this is 0 or this is 1. Means either 1 is related to 1 or 1 is not related to 1. So remember, whatever you take, for example, okay, whatever you take, I comma j, whatever you take, whatever cell you take, this cell has two choices. This cell has two choices. Either it will be 0, means I is not related to j, or this will be 1, means I is related to j. Okay. So very simple that. What this means, let me tell you. This 0 means that I is not related to j. Okay. And this 1 means that I is related to j. Okay. So either this will happen or this will happen. Either I will be related to j or I will not be related to j. One of them can happen. So easily you can see that every cell has two choices. Okay. There are n square cells. And you can see there are two choices per cell. Every cell has two choices. So finally, what is the number of relations? Tell me. What is the number of relations? Number of relations. How many relations will be there? How many binary relations will be there? Every cell has two choices, remember. Okay. So there are total n square cells and every cell has two choices. Every cell has two choices. So finally your answer will be 2 into 2 into 2 into 2 and so on. So the answer will be 2 power n square. This will be your answer. So you can see this matrix representation is a very nice way to count the number of relations. If you want to count the number of relations, then this matrix representation is a very nice way. So easily you can count. So this first is done. Number of relations you want to count, and that is your 2 power n square. Now let's see the second one. Let's see the second one. Now I want to count number of reflexive relations. What I want to count? I want to count number of reflexive relations. I want to count number of reflexive relations. So let's see this. So if you want to count number of reflexive relations, how many reflexive relations are there? Again, this is a nice way. What? So for example, let's calculate on first let's calculate on 5 elements. Okay, let's calculate on 5 elements. Let's calculate. So you can see that this is a very easy way. On 5 elements, if you have a set of 5 elements, then how many reflexive relations will be there? So there are total 5 elements. 1, 2, 3, 4, 5. There are total 5 elements. 1, 2, 3, 4, 5. Okay, 5 elements you have. Now you want reflexive relation. What it means? It means that this one will be related to one. So there is only one choice here. One should be related to one, because reflexive relation means every element should be related to itself, right? Yes or no? This is the reflexive. Reflexive means that for all x, I can say for all x belonging to A, x should be related to x. Okay, so this should happen. This is the definition. This is the definition of reflexive relation, that every element should be related to itself. Now you can easily see that one should be related to one. So here we do not have any choice. Okay, here there is no choice. Similarly, there is no choice here also. Similarly, there is no choice here also. 3 must be related to 3. 4 must be related to 4. So there is no choice here also. And 5 must be related to 5. Okay, 5 must be related to 5. So there is no choice here also. So you can notice this is a 5 by 5 matrix. In this total you have 25 cells you have. In this you have total 20, or I can say 5 square cells you have. 5 square cells you have. Out of these 5 square cells, you can see this diagonal is fixed. We cannot change the diagonal, right? Yes or no? This diagonal is fixed because we want to count number of reflexive relation. So this diagonal should be all 1. The remaining cells can have 2 choices. The remaining cells, like all the remaining cells, you have 2 choices. For example, if you have this remaining cell, this has 2 choices. In this cell you can put 0, or you can put 1. Either 4 is related to 1. This 0 means 4 is not related to 1, and this 1 means 4 is related to 1. So you can here at this point you can easily see that what this means. Let me tell you what this means. This 1 means that 4 is related to 1. And this 0, what this 0 means? This 0 means that 4 is not related to 1. Okay, so this is the point. 4 is related to 1. So either 4 will be related to 1 or 4 will not be related to 1. So for the remaining choices, you have total 2 choices. Okay, so finally what your answer will be? So you can see that total, you want to find out number of reflexive relations. This is what you want to find. Number of reflexive relations. How many number of reflexive relations on set A, such that the cardinality of set A is 5. That is your cardinality. That is your 5 elements. Now you can easily see that in the matrix representation, okay, for this reflexive relation, when you create the matrix representation, so in the matrix representation, what will happen? In this matrix representation, there will be 5 square cells. There will be these 5 square cells. Remember, for these 5 cells, for the diagonal 5 cells, you have only one choice. Okay, so you can see that there are 2 type of cells. One is diagonal, main diagonal cells. So for the main diagonal cells, there is only one choice. There is only one way. Okay, there is only one choice. There is only one choice. All must be 1. What is that one choice? That one choice must be all must be 1. All must be 1. So you can notice for the main diagonal cells, how many main diagonal cells are there? Total 5 cells are there. Right? Yes or no? In the main diagonal, you have total 5 cells. So for these 5 cells, you have one choice only. For the remaining cells, how many remaining cells you have? The remaining cells will be 5 square minus 5, that is 20. 20 cells. For these 20 cells, you have two choices. For these 20 cells, what you have? You have two choices each. There are two choices each. So every cell has two choices. So finally, your answer will be what? So from this, you can easily answer. So the answer is going to be number of reflexive relations. So how many reflexive relations will be there? So for the main diagonal, you have 5 cells. For them, you have one choice. For the remaining 20 cells, you have two choices. So the answer will be 2 power 20. This will be your answer. Now similarly, you can do for n elements. If you have n elements, the same method will work. If you have n elements and you want reflexive relations, the same method will work. 1, 2 and so on n. 1, 2 and so on n. So this is a n by n matrix. So in this n by n matrix, there will be total n square cells in this matrix representation for this reflexive relation. And you can notice the main diagonal will be 1. The main diagonal is going to be 1. This main diagonal has no choice. Okay, this main diagonal must be 1. There is no other choice. For the remaining cells, there are two choices. Whatever remaining cells you take, every remaining cells has two choices. Okay, any remaining cell that you will take, that will be have two choices. So finally, what is the number of reflexive relation? That will be 2 power n square minus n, because these are the n cells. On the main diagonal, you have total n cells. Okay, these n cells have one choice only. The remaining are n square minus n cells. So they have two choices for each. So your answer will be 2 power n square minus n. The reason is very simple. Let me tell you. The reason is basically very simple. You want number of reflexive relation. This is what you want. And for the reflexive relation, when you create the matrix representation, this matrix representation you create, in this matrix representation, there will be n square cells will be there. From these n square cells, there will be n main diagonal cells. N are diagonal. N cells are diagonal. Okay. And the remaining cells, n square minus n. These many cells are the remaining. These many are the remaining cells, n square minus n. So for these cells, there will be one choice. One choice. Only one choice you have. One choice for each cell. For each cell, there will be only one choice. And here you have total two choices for each cell. Two choices for each cell. So number of reflexive relation will be 2 power n square minus n. This will be your final answer. So this is the complete explanation how you can calculate number of reflexive relations. Like this is a gate question you can see. In this gate question, reflexive relation he is asking. So that will be 2 power 20. So the answer will be option C. Okay, 2 power 20. If you have total n elements, then number of reflexive relation will be 2 power n square minus n. So easily you can calculate. So the answer is going to be 2 power n square minus n. Okay, so quite easily you can do it. Okay, let's see the remaining. Like we can solve the remaining questions also. For example, if I ask you how many irreflexive relation, can you tell me how many irreflexive relation? What that will be? Number of irreflexive. How many irreflexive relations are there? What that will be? Number of irreflexive relations. So what is going to be? So again the same way, the same method actually, because irreflexive means on the main diagonal you have all the zeros. Okay, what will happen now? Now this will happen that on the main diagonal you have zeros. Irreflexive means no element is related to itself. Okay, no element should be related to itself. So basically this value must be 0. Similarly, this value must be 0. This value must be 0. The main diagonal should have all zeros. So for the main diagonal, again you have one choice only. For the main diagonal, again you have only one choice. This is your main diagonal. Okay. So for the main diagonal, you only have one choice. Okay, so this is fixed. This main diagonal is, I can say this is fixed. This is fixed diagonal. this diagonal must be all zeros, because irreflexive means no element is related to itself. Okay, irreflexive, it means there is no element which is related to itself. Okay, so this is your fixed diagonal. The remaining elements, the remaining cells have two choices. If you take any remaining cell, that will have two choices. Okay, whatever remaining cell you take, that remaining cell will have two choices. So number of irreflexive relation, what that will be? That will be same number of irreflexive relations. So that will be equal to 2 power n square minus n. So this will be your answer, 2 power n square minus n. Okay, is this clear? The same way, because the main diagonal is fixed. The main diagonal will be 0, 0, 0, 0. The remaining cells, how many remaining cells? These are the remaining cells, n square minus n. The remaining cells, n square minus n, these are the remaining cells. These remaining cells have two choices each. Every remaining cell has two choices. So the answer will be 2 power n square minus n. This is your number of irreflexive relations. Okay. So if I ask you, what is the number of relations which are not reflexive? What that will be? Number of not reflexive relations. What that will be? How many relations are not reflexive? Not reflexive relations. So that will be total relations, total number of relations minus number of reflexive relations, correct? Minus number of reflexive relations. So total number of relations are what? That is 2 power n square. This is the total number of relations, minus number of reflexive relations, that will be 2 power n square minus n. So like this you can calculate the number of not reflexive relations. These are the not reflexive. These relations are not reflexive. Okay, very easily you can calculate. Like this you can ask. For example, they can also ask you, what is the number of relations which are neither reflexive nor irreflexive? Tell me, what is the number of relations which are neither reflexive nor irreflexive? What that will be? So again the answer will be total minus number of from this you from the total number of relations. Okay, so from the total number of relations you remove number of reflexive relations, you also remove number of irreflexive relations. So these you remove. So your answer will be like 2 power n square minus 2 power n square minus n minus 2 power n square minus n. So this will be your answer. Okay, or you can write it, basically you can write it as 2 power n square minus 2 power, okay, 2 power, because these are basically same, so you can just double it. So that will be like 2 power n square minus n plus 1. Like this also you can write. Okay, like this also you can write. So this will be 2 power n square minus n plus 1. Okay, so this will be your answer. Because you can see these are the same. So it's just double of this value. So 2 power, you can just double this value basically. Okay, so if you see this, that is your, I can say, double of this value, and that will be n square minus n plus 1. So this will be your answer. Okay, let's move on. So let's see the next variation is how many asymmetric relations, like let's find out number of symmetric relations. Okay, let's see what is the number of symmetric relations. What that will be? Tell me, how many symmetric relations are there? What will be the number of symmetric relations? So number of symmetric relations, again the same thing will happen. Again exactly the same thing will happen, that in the symmetric relation what will happen? You must have a symmetric matrix. The symmetric matrix you must have, right? Okay, you must have a symmetric matrix. So because you have symmetric relation, that means this matrix must be symmetric. This must be symmetric matrix. This matrix must be symmetric. So if I call this matrix M, then symmetric matrix means M must be equal to M transpose. M should be equal to M transpose, correct? This is the meaning of symmetric relation. Symmetric relation means that if A related to B, then B should be related to A, right? Yes or no? If A is related to B, then B should be related to A. This is the meaning of symmetric relation. Okay, so now let's see. So now, how many symmetric matrices you can create? So this is a very simple point. Every entry is 0 or 1. So what will happen? See this will happen. Very simple thing. For every diagonal, you have two choices. For every diagonal, there will be two choices. So for this diagonal, there is no problem. For this diagonal, I can say like this. What I can say? I can say above the diagonal. If you see above the diagonal, okay, like see, this is your diagonal. This is your diagonal. This is the diagonal. Now you can notice that. In this diagonal, every element has two choices. Okay. In this diagonal, every element has two choices. So in this diagonal, I can say two choices. In this diagonal, every element has two choices. Every cell has two choices. Now look at above diagonal. Look at this area. Look at this area. Okay, look at this area. In this area, you can see that whatever you have here, whatever you have, for example, whatever you have 1,3, that same value must be here. Yes or no? Correct? That same value. For example, if this is 0, then same 0 you must have here. Similarly, if you have, for example, if you have 1 here, then the same 1 you must have here. So you can see this should be replica. I can say that this triangular, this should be replicated here. This triangular should be replicated here. So they must be basically, I can say they must be replica. They must be mirror image of each other. Yes or no? So I can say whatever you have here, that same value you have here. Okay. So something like this. So finally I can say how many choices do we have? So let's see. So you can see we want number of symmetric relations. You want number of symmetric relations. Then you can see that every diagonal element has two choices. So I can say 2 power n. These n are the diagonal elements. These are the diagonal cells. Okay, these are the diagonal cells. So every diagonal has two choices multiplied with 2 power. You can see that how many elements are here in this. In this you have total n square minus n divided by 2 elements, right? Yes or no? Because you are removing these diagonal cells. So you can remove these diagonal cells, and then finally you can say that once I remove these diagonal cells, if I remove, then divide by 2. So these many cells you have, correct? Okay, yes or no? So you have these many cells. So finally I can say that it will be like n square minus n divided by 2. Remember one thing, that whatever you put here, that will automatically be replicated here. So this is the mirror. Okay, so this is like whatever you do here, that will automatically come here. So you can fill this. Once you fill this, it will automatically fill. Okay, once you fill this, it will automatically fill. So you don't have any choice here. Once you fill this, okay, very simple observation, that once you fill this, once you fill these entries, then there is only one choice here. There is only one choice here, because it will be replicated. It will be replicated. So I can simply say that your answer will be this: 2 power n multiplied by 2 power n square minus n by 2. So that will be equal to 2 power n square minus n by 2 plus n. And that will be what? That will be 2 power n square plus n by 2. Okay. So this will be your final answer. Okay. I hope this is understood. So the answer will be 2 power n square plus n by 2. Okay. This is your number of symmetric relations. Or you can simply say that your answer is this. This is your answer. Okay. So I hope you understood this. Now let's move on. Now let's see the number of asymmetric relations. Number of asymmetric. What is the number of asymmetric relations? How many asymmetric relations are there? So let's calculate this number of asymmetric relations. So what this asymmetric relation says, let me tell you. This asymmetric relation, what it says. Asymmetric, it means that diagonal must be 0. Yes or no? All the diagonal entries must be 0. So for example, if you have 1, 2, 3, 1, 2, 3, then all these diagonal elements must be 0. This must be 0, this must be 0, this must be 0. Because I am talking about asymmetric. Asymmetric relation means if A related to B, then B is not related to A. So in this asymmetric, reflexive pairs are not allowed, right? Yes or no? In the asymmetric, reflexive pairs not allowed. Reflexive pairs are also not allowed. So you can easily say that this diagonal will have 0. All these diagonal entries, this diagonal will be basically 0. This is your diagonal. And this diagonal is going to be 0. Okay. After this, it cannot happen that this is also 1, this is also 1. Okay, it cannot happen that this is also 1, this is also 1. Agree? This cannot happen. So, okay, everything else is possible. Look at this cell. Please understand this cell and this cell. Look at this cell and look at this cell. These two cells. How many choices these two cells have combined? Like this combination has how many choices? Look at this combination. Look at this combination. How many choices this combination has? Tell me. How many choices this combination has? Look at this combination. So look at this combination and tell me how many choices this combination has. So let me tell you, this combination has total 3 choices. This combination, it has total 3 choices. What are the 3 choices? Both can be 0. Okay, both can be 0, or 1 can be 0, 1 can be 1, or 1 can be 1, 1 can be 0. So remember this combination. This combination has 3 choices. Similarly, look at this combination. Similarly, look at this combination. This combination 1, 3, 3, 1. This combination. So how many choices this combination has? Tell me. Look at this combination and tell me how many choices this combination has. So this combination also has 3 choices. What are the 3 choices? Both can be 0, 1 can be 0, 1 can be 1, 1 can be 1, 1 can be 0. Okay. So like this. So I hope you understood that what I am saying. I am saying that basically this will happen. This will happen that when you have like 1, 2, 3, 4, 1, 2, 3, 4, then something like this will happen that all the diagonal will be 0. Diagonal will be 0. This diagonal is going to be 0. Okay, this diagonal will be 0. And after this diagonal, if you see, then I can simply say that this combination will have 3 choices. Okay, this combination will have 3 choices. This is what I am saying, that this combination will have total 3 choices. Similarly, this combination will have 3 choices. Like I can say this look at this combination. This combination will have 3 choices. Similarly, I can say that this combination, like if you take 2, 4. Okay, so if you take this 2, 4 or 4, 2, so this combination has 3 choices. Again, this also has 3 choices. So like this. So finally, your answer will be what? Answer will be 3 power. How many such pairs you have? Tell me. How many such pairs you have? Like these things are happening in pair. Please understand that. Like these are the pairs. So how many pairs you have? So number of pairs will be how many cells are there in this area. In this area, how many cells you have? Just calculate that. Just calculate how many cells you have in this area. Look at this area. Look at this area. So in this area, how many cells you have? In this area, you have total n square minus n by 2 cells. And that will be your number of these combination, these pairs. So it will be 3 power n square minus n. 3 power n square minus n by 2. This will be your answer. So did you understand this? So number of asymmetric relations. Did you understand that? Number of asymmetric relations will be 3 power n square minus n by 2. This will be your answer. Okay. Is this understood? Please tell me. Is this understood? Now tell me number of antisymmetric. Now if I ask you number of antisymmetric relations, what that will be? Number of antisymmetric relations, what that is going to be? What will be the number of antisymmetric relations? Remember, antisymmetric relation is nothing but asymmetric plus possibly reflexive pairs. What is antisymmetric? So let me tell you, this antisymmetric, this is basically same as asymmetric. This is basically asymmetric with reflexive pairs allowed. Reflexive pairs allowed. Reflexive pairs are allowed. Okay. So all the reflexive pairs will be allowed. So finally, what will happen in the antisymmetric? So it will happen that this will be the number of asymmetric. Asymmetric is this, right? 3 power this. This is your number of asymmetric relations multiplied by 2 power n. Multiplied by 2 power n. Because now reflexive pairs are allowed. Okay, 2 choices for each diagonal. 2 choices for each. 2 choices each for diagonal elements. Now the diagonal elements have two choices. Okay, all the diagonal elements, they have two choices. Is this clear? So 2 power n multiplied by 3 power n square minus 1 n by 2. So this will be your answer. I hope you understood. See, very simple. It is very, very, very simple. What is antisymmetric? Antisymmetric means that this will happen that in antisymmetric, these diagonal elements, if you have 1, 2, 3, 4, if you have 1, 2, 3, 4, all these diagonal elements have two choices. This diagonal element can be like 0 or 1. It can be 0 or 1. It can be 0 or 1. It can be 0 or 1. So the diagonal elements have two choices. Look at this diagonal. Okay, so every diagonal element has two choices. The remaining is same. The remaining thing is same. For example, if you have whatever you have here, so these two will have 3 choices. Okay, these two will have total 3 choices. Similarly, for example, this 1, 3, 3, 1, these two have total again 3 choices. This and this, they again have 3 choices. Similarly, for example, if you have 4, 2, 2, 4, okay, then they also have basically 3 choices. They also have basically 3 choices. So this is what I am saying. So what I am saying is that your answer will be 3 power n square minus n by 2 multiplied by 2 power n. Okay, because now the diagonal elements have two choices each. Every diagonal element has 2 choices each. So this will be your number of antisymmetric relation. Okay, so we have counted the number of all the possible relations. Let me tell you that number of transitive relations is not easy to calculate. How many transitive relations are there? So number of transitive relations, this is not easy to calculate. Okay, so in the GATE exam, if they ask you, they will ask you a very easy question on this, but I will cover this. Okay, so you can watch on the goclass YouTube channel. You can watch the lecture like transitive closure. So those lectures you can watch, then you can easily understand this. Okay, how many transitive relations are there? But anyway, this is not easy to calculate. Let me tell you, this is not easy to calculate. So in the GATE exam, actually there is no question on this. Okay, from the transitive relation, how many transitive relations are there? In the GATE exam, there is no question on this. As I told you, this is not easy to calculate. If they ask you in the GATE exam, if they ask you, then they can ask you a very small question. They can ask you maybe 2 element, 3 element. Okay, so they can ask you a set of 2 elements, set of 3 elements, and they can ask you. But anyway, this we will cover. Don't worry. This number of transitive relation. If you want to watch it, then this you can watch on goclass YouTube channel. There is a video transitive closure. So basically on the goclass YouTube channel, you can find this. So today I will teach the transitive closure and all those things. Adjacency matrix power, those videos are already available on the goclass YouTube channel. The power of adjacency matrix. In the GATE exam, last 2 years, there are 4 questions from this topic, adjacency power. Like you have adjacency matrix, matrix representation, and what is the power of adjacency matrix? What information it gives you? the power of adjacency matrix, what information it will give you on that there are multiple questions. There are 4 questions in the last 2 years in the GATE exam, and that is an important point. That is a very important topic, and that you can easily find on the GoClasses YouTube channel. The complete video, the complete analysis you can find on GoClasses YouTube channel. Okay. Anyway, so let's move on now. Tell me the answer for this question. What is the answer? So we have seen the number of relations. Counting the number of relations that we have seen. So you tell me the answer here. So this is GATE 2020 GATE 2020 question. So the question is saying that R is a set of all binary relations on set. So this is set of all binary relations. So what is the cardinality of R? Tell me. What is the cardinality of R? Tell me. What is the cardinality of R? Remember, this is set of all binary relations. So how many binary relations are there? So that will be equal to 2 power n square. Okay, so n is equal to 3. So that will be equal to 2 power 9. Because n is equal to 3. The question is saying n is equal to 3. So R is basically set of all binary relations. So the cardinality of R will be 2 power 9. That will be the cardinality of R. Okay. Suppose a relation is chosen from R at random. We are randomly choosing one relation from R. Okay. Because remember, this R is set of all binary relations. This R is not a relation. This is set of all relations. This is set of all binary relations. So how many binary relations are there? That is your 2 power 9, or I can say 2 power n square. Now you are choosing one relation from this R. Okay, randomly you are choosing one relation from this R. You are choosing at random. The probability that the chosen relation is reflexive. The probability the chosen relation is reflexive. First of all, how many reflexive relations are there? First of all, what is the number of reflexive relations? What is that? Number of reflexive relations. What that will be? So number of reflexive relations will be 2 power. Number of reflexive relations, that is going to be 2 power. Remember, in the reflexive relation, all the main diagonal will be 1. Okay, so the answer will be number of reflexive relation will be 2 power n square minus n. So that is your 2 power 3 square. So that is your basically 2 power 6. So these many reflexive relations you have. Now, so in this R is set of all relations. This R is set of all binary relations. Okay, this R is set of all binary relations. In this R, tell me, in this R, how many relations are reflexive? In this R, how many relations are reflexive? What is the cardinality of R? We already know. The cardinality of R, that is 2 power 9. How many reflexive relations are there in this R? So that is 2 power 6. So what is the probability? You are choosing one relation. What is the probability that it will be? So you are choosing one relation. Then what is the probability? So the answer will be, you can calculate, that will be 2 power 6 divided by 2 power 9. Okay. Let me ask you one variation. You can try this question. Try this one. Let me connect my laptop to the charger. So you can try this question. Hello. Hi everyone. So yeah, we were discussing this question, this GATE 2020 question. So this look at this relation R. This is set of all binary relations. In this R, you have all the binary relations. So the cardinality of R is 2 power 9, and number of reflexive relation in this R, that is 2 power 6. And the question is asking probability. You are choosing one relation. So what is the probability that the chosen relation, the question is asking probability of choosing reflexive relation from R. Okay, from R you are choosing one reflexive relation. So what is the probability of choosing reflexive relation from R? That will be equal to, remember, 2 power 6. These are the reflexive relations. 2 power 6, this is the number of reflexive relations in this R, and total number of relations in this R, that is 2 power 9. This is the probability of choosing reflexive relation from R. Basically, number of favorable cases divided by number of total cases. Okay, so this is your answer. Answer will be 1 divided by 2 power 3. Now the question is asking, okay, so that's it. So the question will be, the what is the probability? Round off to 3 decimal places. So the answer will be 1 divided by 8. You can calculate this. 1 divided by 8. What is the value? You can calculate. Okay, so you have to give your answer up to round off to 3 decimal places. Remember your answer. You should give your answer to 3 decimal places. So you can just easily calculate this. So that will be 0.125. Okay, your answer for this question, your answer will be 0.125. This answer you have to put. Okay, now let me ask you one variation. What beautiful variation they can ask you in this question. In this question, what variation they can ask? So let me tell you that this is a beautiful variation they can ask you. Assume that this R is given to you as set of all symmetric relations. Assume this is given, that assume that R is given to you as set of all symmetric relations. Okay, now the question is asking, what is the probability of choosing reflexive relation from R? Choosing reflexive relation from R. Now tell me the answer. Are you getting this variation? Please tell me, did you understand this variation? So this is a variation they can ask you. What they can do, they can give you that relation R is a set of all symmetric relations. So what this relation are? This is set of all symmetric relations. And now we are finding what is the probability of choosing a reflexive relation. You are choosing reflexive relation from R. What is the probability of that? This type of question they can ask you. This is another variation they can ask you. So now you can see what is the cardinality of R. First of all, you tell me what is the cardinality, what is the number of relations on R. So this is a, first of all, you can see this is the variation. Now you tell me one by one, what is the cardinality of R? What that will be? How many symmetric relations are there? What is the number of symmetric relations? So that will be 2 power n square plus by n by 2. Okay, so this will be 2 power, that will be n is 3. So 3 square, that is 9 plus 3. So that will be like 6, 2 power 6. So R, cardinality of R will be 2 power 6. Okay, because these many symmetric relations you have. Now in this R, how many reflexive you have? Tell me, in this R, do we have 2 power 6 reflexive relations? Can I say we have 2 power 6 reflexive relations? This is wrong, right? Yes or no? This is wrong. Correct? This is wrong, because in this R, how many reflexive relation you have? You have to find that. In this R, how many reflexive relations are there? Remember, number of all symmetric relations. So the cardinality of R will be 2 power 6. This is the cardinality of R. The cardinality of R is 2 power 6. Now, in this R, how many? So this is your relation R. Basically, in the relation R, this is your set of all symmetric relations. Set of all symmetric relations. Now, in this, how many reflexive you have? In this, how many reflexive? in this, how many reflexive relations you have? In this, tell me how many reflexive relations we have in this. So now you can calculate this very easily. How many reflexive relations are there? You can easily calculate this. Basically, we want to find how many symmetric and reflexive relations. So this is the calculation we want to have. How many how many relations which are symmetric and reflexive. So what is that? Number of relations which are symmetric and reflexive. So remember, symmetric and reflexive means all these diagonal will be 1. All the main diagonals will be 1. All your main diagonals will be 1. Now the remaining thing is same. Remaining thing is same. So the main diagonal will be 1. And how many elements you have here? That will be n square n by 2. So the answer will be 2 power n square minus n by 2. This will be your value. Correct? This will be your value. Okay. So finally, you can find out the answer will be how many reflexive relations. So in this set R, how many reflexive relations? That will be equal to number of symmetric and reflexive relations. And that will be equal to 2 power n square minus n by 2. And that is going to be 2 power 3. Okay, that is going to be 2 power 3. So your final answer will be what? Your final answer will be what? The probability of choosing that will be 2 power 3 divided by 2 power 6. Okay, so your answer is same, but the method is different. Is this understood? Please tell me, Yuvraj, is this variation understood? This type of variation they can ask you. They can ask you basically a set is a symmetric relation. In this R you have set of all symmetric relations. Now they are asking you what is the probability of choosing reflexive relation from R. In this R, how many reflexive relations are there? So that will be, this is your answer. Okay, so like this you can very easily calculate. Okay, let's move on now. Let's see this question. This is a CMI question. You can see CMI 2020 data science B question number 13. R is set of all binary relations. This relation R, this is set of all binary relations. So first of all, what is the cardinality of R? The cardinality of R will be 2 power 9. Okay, that will be the cardinality of R. You are choosing a relation at random. It is symmetric. So first of all, what is the number of symmetric relations? What is the number of symmetric relations? So number of symmetric relations will be 2 power n square plus n by 2. That will be equal to 2 power 6. Okay, so that is going to be 2 power 6. So your answer will be what? So for this question, what is the probability? The probability will be 2 power 6 divided by 2 power 9. That will be 1 by 8. Okay, so the probability is going to be 1 by 8. Okay, clear? So easily you can see. So that will be your probability, 1 by 8. Very simple question. Now let's move on. Now let's see this one. Number of equivalence relations. How to calculate number of equivalence relations? How to calculate that? So let me tell you, if you want to calculate number of equivalence relations, then that is equal to number of partitions. Yes or no? So if you have, for example, if you have a base set, A, okay, then what is the number of equivalence relations? Number of equivalence relations on A, that will be same as number of partitions of A. That will be same as number of partitions of A. How many partitions can you create of A? Okay, so number of equivalence relations will be same as number of partitions of A, because remember, every equivalence relation on A will give you a partition of A, and every partition of A corresponds to equivalence relation on A. So this is something like if and only if. Okay, means every equivalence relation on A will give you a partition of A, and every partition of A corresponds to equivalence relation on A. Okay, so you can just calculate. So let me tell you that here what will happen. So let me tell you, you can calculate like this. Like here the question is saying that your base set has 4 elements. Okay, so you have your base set A has total 4 elements, that is 1 2 3 4. There are total 4 elements in this base set. So just find out how many partitions you can create. Just find out how many partitions can you create. This will be your answer. Number of partitions you can find out, and that is equal to, let me tell you one more thing, that is equal to how many partitions you can create. That will be equal to, basically it is a distinguishable objects identical boxes problem. This is a problem where you have distinguishable objects identical boxes. Okay, means your boxes are identical but your objects are distinguishable. So this is a problem. So number of partitions will be equal to, basically that is your DOIB problem. You can learn it. What is DOIB, IODB, DODB, and IOIB? All these things you can understand in the GoClasses Discrete Mathematics course. Discrete Mathematics, complete Discrete Mathematics is freely available for all the students on the GoClasses website. Okay, so you can study what is DOIB, IODB, IOIB, DODB. Okay, all these things you can easily understand with many questions, with many variations in the GoClasses Discrete Mathematics course. Okay, so on the GoClasses website you can study complete Discrete Mathematics. You can study for free. It is free for all the students. Okay, so this is basically a DOIB problem. Anyway, so let's see this. So what will be the number of partitions? So you can go step by step. How many partitions are there? You can go step by step. First you can calculate how many one part partitions. How many one part partitions are there? So tell me how many one part partitions will be there? Only one, yes or no? How many one part partitions will be there? That number of ways will be only one. Okay, that will be only one, because you have one part. One part means all of them will be in a single part. Okay, so all of them, they will be in a single part. All of them will be together. All of them will be together. So only one way is there. Okay, let's calculate how many two part partitions are there. What will be the number of two part partitions? So let's calculate. You want two part partitions, you want, means there will be two categories. There will be two categories. So either you can create category like this 1, 3, or you can category like this, you can separate like this 2, 2. So either you can separate 1, 3, or you can separate 2, 2. So these are the two separations you can do. If you do separation like this 1, 3, if you do separation like this, then here basically one element you are separating. There are 4 friends. You can understand like this, that it's like there are 4 friends. There are 4 friends. They are going to a picnic. Okay, and you can see one friend is living in a separate room, 3 friends are living together. So here easily you can see how many ways are there. So that will be 4 ways. Means which friend is separate, you can select which friend is separate. Okay, which friend is separate you can select. Automatically the remaining 3 friends will be together. Similarly, you can select which 2 friends are together. Which 2 friends are together. Okay, you can select, like you can select 2 together, 2 together. Okay, so you can select which 2 friends are together, you can select. But you have to divide by 2. You have to divide by 2, because remember, order doesn't matter. This order doesn't matter. Okay, so you can see this is, I can say, unordered. The order doesn't matter, because ultimately this is, as I told you, these are identical boxes. Distinguishable, like 4 friends going to 2 rooms, and the rooms are same. So this is unordered. So that is the reason you have to divide by 2. You have to divide by 2 because this is unordered. So what is this 4C2? 4C2 you can calculate. So that will be 6 divided by 2, that will be 3. So that will be 3 ways. Okay. What else? Now you can also create 3-part partition. How many 3-part partitions are there? What will be the 3-part partitions? So when you are creating 3-part partition, then basically 3 rooms you have to use. Okay. Then automatically you can see only this is the possibility 2, 1, 1. So here answer will be 4C2. Which 2 friends are together? Which 2 friends are together? So that will be 6. Okay. Then finally 4-part partition. That will be only 1. Okay. Only unique, only one way. Only there is only one way. Only one way. So finally your answer will be what? So number of partitions. How many partitions are possible? So number of partitions, that is equal to number of equivalence relations. That is equal to number of equivalence relations. So how many equivalence relations are possible? How many partitions are possible? The answer will be 1 plus 4 plus 3, 1 plus 4 plus 3 plus 6 plus 1. Okay, so the answer is 15. So for this question, the answer is going to be 15. Okay, so very simple. You can do this question. Answer will be option A. So like this, you can calculate number of equivalence relations. So whenever you want to calculate number of equivalence relation, that is same as number of partitions. Always go step by step. Remember, always this DOIB problem, when you have this DOIB problem, always go step by step. The best way, what is the best way? The best way is go step by step. Go step by step. This is the best way if you want to solve DOIB problem. Okay, so let's move on now. This is the another question. This is another GATE 1998 question. So tell me what is the answer here. Suppose A is a finite set with n elements. The number of elements in the largest equivalence relation. What is the largest equivalence relation you can create? Tell me what is the largest? What is the largest equivalence relation on A? So that will be your A cross A. Because A cross A is the largest relation you can create, first of all. Actually, largest relation, this is the largest relation you can create. This is the largest relation we can create. And this is also equivalence relation. Let me tell you, this A cross A, this is also equivalence relation because this is transitive, reflexive and symmetric. So this is also equivalence relation. This is also equivalence relation. So this is the largest relation you can create, and this is also equivalence relation. So the question is asking what is the number of elements in the largest relation. So in this number of elements will be what? In this number of elements will be n square elements. In this total n square elements you have. So your answer will be option B. Okay. Answer is option B because you have total. This is the this A cross A. Let me tell you, this is equivalence relation. This is the largest relation you can create because every relation is a subset of A cross A. Every relation is subset of A cross A. So this is the largest you can create. This relation, this A cross A, this is the largest relation you can create. Okay, so that's it. So this is your answer. Now, yes, very good. See, the largest equivalence relation means what happens if your relation is largest. If your relation is largest equivalence relation, then what it simply means? It simply means that you have only one equivalence class. You have only one equivalence class. If you have only one equivalence class, if you have only one equivalence class, it means you have only one part partition. You have only one part partition. Okay, and if you have one part partition, then it simply means that all elements related to all elements. Okay, it simply means that all elements related to all elements. Related to all elements. All elements related to all elements. Every element related to every element. And that is your n square. So this will be the largest equivalence relation cardinality. That will be n square pairs. N square ordered pairs. Okay. So this is your answer, n square. For this question, the answer will be n square. Tell me what is the answer for this question? This is the last question, GATE 2007. You have a set of n elements. There is a set of n elements. The number of ordered pairs in the largest and smallest equivalence relation. See, the largest equivalence relation will be A cross A. This A cross A is the largest equivalence relation. This is reflexive also. This is symmetric also. And this is transitive also. Okay, so the largest equivalence relation will have, I can say the answer will be n square. What is the smallest equivalence relation? What is the smallest equivalence relation? Let me tell you, at least it must be reflexive, right? Yes or no? The smallest equivalence relation is like this. If you want smallest equivalence relation, then what that will be? You want smallest equivalence relation. Smallest equivalence relation means that every element is related to only itself. So this is the smallest equivalence relation where every element is related to only itself. Like you have Like you have these elements 1, 2 and so on n, 1, 2 and so on n. Your smallest equivalence relation, it should be reflexive. So every element should be related to itself. The remaining should be 0 because you want smallest equivalence relation. You want smallest equivalence relation, so the remaining is 0. So smallest equivalence relation means maximum number of equivalence classes. Maximum number of equivalence classes. Maximum number of equivalence classes means basically one part, one element, an element is already, I can say one element per equivalence class. One element per equivalence class. One element per equivalence class. So this is your answer. So in one equivalence class, you have only one element. So the cardinality. So this is the smallest equivalence relation. Let me tell you. What is the smallest equivalence relation? It must be reflexive. Okay, this must be reflexive. This must be symmetric. This must be transitive. So because it must be reflexive, so the smallest equivalence relation will be this one, identity relation. The smallest equivalence relation will be identity relation. Identity relation means what? Your identity relation means this relation, a comma a, where a belongs to base set. This is called identity relation. Means every element is related to itself. Every element is related to only itself. So very simple. So this is your identity relation. So the cardinality will be what? What is the cardinality of identity relation? That will be only n. N reflexive pairs are there. You can see. So here the smallest equivalence relation cardinality will be n. So that will be n. So the answer is going to be n square comma n. Very simple. So these are the questions related to counting the number of relations. Okay. I hope all these points are clear. Anyone has any doubt in these? All the questions we have done, we are done with the counting the number of relations. So this topic is done. Basically counting relations. This topic we have seen. Counting relations. All the questions, all the variations, this is done. This is completed. Okay, this is completed. So this is enough in the relations. The remaining things you can do yourself. Okay, a lot of questions, a lot of gate questions, a lot of concepts, revision, the complete revision, all the complete summary we have seen. So I hope you understood all the points. So this is enough in the relations. Now what we will do in the next lecture, basically we are going to start this graph theory. Okay. So next is going to be revision plus gate PYQ of graph theory. This will be our next topic in the revision classes. This we will start tomorrow. Okay. So tomorrow we are going to start revision, summary and gate PYQ of graph theory. This is what we are going to see. Okay. And also today we have another session. Today we have dbms revision plus gate PYQ is also there. So you can check it out on the goclasses YouTube channel. This next session will be dbms revision. This dbms revision has also started. Okay, one lecture is already uploaded. Okay, so lecture 1 is done. You can find on the goclasses YouTube channel, and lecture 2 will be today. Okay, today we have lecture 2. So you can this you can find on the goclasses YouTube channel. Okay, goclasses YouTube channel. Just go to the playlist. You can search for the playlist. Okay. So thank you everyone. And so once we complete this dbms, then we will start theory of computation, digital logic. Those also we will start. Also let me tell you, computer network revision is also going on. So operating system is over. So what we have done, operating system revision, this is over. Operating system revision is over. And this discrete mathematics revision is almost over. this discrete mathematics revision, this is almost over. This is almost over. Right now dbms is going on, dbms revision is going on, and also cn revision, these are going on. Okay, so this is what is going on. Okay, revision plus gate pyqs, revision plus gate pyqs plus summary. Okay. Okay, thank you everyone. So please comment on this session. Yes, now the session will be regular. Sumant, all these session, all these classes, now they will be regular till the gate exam. Okay, they will be every day we will have these sessions and multiple sessions actually. Sumant, we will have multiple sessions. Like today we have 2 sessions, and also tomorrow also there will be like 2-3 sessions we will have. So we will make sure that all the subjects are covered. Okay, toc, digital logic, computer organization. Okay, so all the subjects that are there, we will cover all the subjects. Okay, so there will be regular sessions will be there from today onwards. Today we have another session, as I told you, there is another session, lecture 2, this is today. Okay, and tomorrow we will start graph theory, revision plus gate pyqs of graph theory. Okay, so thank you everyone, thank you so much. I hope you loved the session. So if you like the session, please like and comment on the session. Okay, what your feedback, your what did you like, did you learn something new? Okay, so please please comment your feedback, please comment your review. Whenever you are watching any video on GoClasses YouTube channel, please put your comment. Okay, we go through all the comments, and your comments, your review, your feedback will tell us what more what more can we provide. Okay, more variations, more standard questions. Okay, so which topic we should provide on the GoClasses YouTube channel, in which topic you are not comfortable. So basically, like, what did you like? Okay, so all the things you just put in the comments. So whenever you are watching any video on the GoClasses YouTube channel, please like and comment. Okay, on this video also, please like and comment. Okay, thank you everyone. See you today in the dbms revision session. Thank you.